Welcome back. This is an Aleks homework video on predicting qualitatively how entropy changes with mixing and separation. Okay, pretty easy concept here. If you put stuff together, you're going to make it more random. Okay, anytime you assemble a mixture or even dissolve something in water where you have one substance in another substance, or dissolve something in alcohol or whatever, when you're putting two substances together or more than two substances together, you've got more molecules there that are going to be randomly placed. The entropy is essentially a measurement of the chaos of that system. How random is it? So if I think of a sugar cube, all nice and together, one material, that is very orderly with a low entropy. If I dissolve that in water and the sugar kind of goes everywhere, that's more chaos, that's more randomness. That's going to be a higher entropy. So if for whatever reason you can take that sugar water and get the water out, okay, somehow evaporate all that water and return that to sugar crystals, then that's less entropy. So if you have a mixture that you can somehow separate, entropy will go down. If you're adding something to your mixture, more molecules of some type, entropy will go up. Okay, so I hope those two kind of rules of thumb will help you here. And of course, you're going to have some of your questions will be separation, and where they go down more to a pure substance, and you'll have a negative entropy. Some will be where you're adding molecules, you have more chaos, and you'll have a positive entropy. So hard to anticipate every possible question you have. But just stay with that idea, okay? So the first one, I have a mixture. I shouldn't have shown you so fast. You have a mixture of carbon dioxide and hydrogen already. Now, if you add the stuff, as long as the temperature doesn't go up. Now, if the temperature goes up, it's possible that the randomness or your entropy will stay put, because that, the play is all based upon whatever's in the formula. So if temperature is constant and the total volume, like total of everything together, doesn't move, then those are your only exits on the highway. If all of those are solid, then you can anticipate that if you add them together, you're going to have more entropy. So I've got carbon dioxide, hydrogen as a mixture. I'm adding more hydrogen, I'm adding more material, I'm adding more molecules. I have more randomness. Because of that, I have a higher entropy. My entropy has gone up. Okay? So the second one, I've got potassium iodide, I've got water. They're separated. So I've got two pure substances, and I'm going to dissolve the salt in the water. Okay, you know that the potassium ions and the iodine ions will separate, and you're going to have more randomness, more chaos. So when you dissolve it, you're going to have more entropy as a reason. Okay, so entropy will go up in this case also. In the third example I have here, I've got a solution of potassium iodide already in the water, and I'm adding more water. Okay, I'm adding more molecules. If you add more molecules, there's more places for those ions to float. There's more places for them to be. It mixes around in a larger place, so it's more random. And since it's more random, it's more entropy. Okay? So I hope this helps you. I hope you think it's easy now.